CPU and top-level CPUs. Our overview is what is CPU, history of CPU, usage areas of CPU, quantum processor and computer, popular CPU. The first question is that the central processing unit called CPU is the computer component that is responsible for interpreting and executing most of the commands from the computer's hardware and software. Let's have a look at what does the CPU do and why do we see it generally in the old machines. The CPU's main function is take input from an auxiliary device like keyboard, like mouse, or a printer, or it can be a computer program. Then interpret what it needs and output the information to your screen or perform that device request. The second question is, what are the components of the CPU? There are many variations in CPU designs, but most of them have the following key components. First one is the electronic clock. The clock regulates the rate of the CPU runs and synchronizes all the computer components. And if the frequency of the clock is high, it means that the CPU can execute more instructions per second. And while defining the speed of the CPU, we use megahertz. Second one is the control unit. Control unit does the controlling of the links between the other components of the CPU. And instruction unit, which consists of the arithmetic logic unit, the floating point unit, and registers. The arithmetic logic unit executes basic arithmetic operation or logical operation like addition, subtraction, or XOR, or and NOT logical operation. The floating point unit performs math operation on floating point, and various registers such as the accumulator that are used in instruction while executing. And bus. There are three types of buses: address bus, data bus, and control bus. Address bus are used to set which memory address that CPU content is linked to for read or write operation. And data bus is used to exchange data between memory address and CPU when a read or write operation happens. And the control bus is used to transfer common codes and status signal between return the status signal between the CPU and external devices. The other one is bus management unit. Bus management unit manages the transfer of data. And here, as you see, is the structure of the CPU. There are three functions of the CPU. First one is fetching, decoding, and executing. In the fetching, the binary instruction is taken from a memory address and stored in the current instruction register. And then the memory address of that instruction is stored in a register that's called program counter. After an instruction is fetched, the program counter is updated because CPU has to know the memory address of the next instruction. In decoding, CPU is identifying the operation code called opcode, like move, and in executing, here the control units links the part of the CPU that are needed to execute that instruction. For example, if your instruction includes an arithmetic basic operation, then arithmetic logic unit connects with that relevant memory to execute it. What about CPU characteristic versus performance? First one is clock speed. The higher the clock speed, the more instructions the CPU can execute per second, resulting in a faster running computer system. The speed that the processor executes instructions is controlled by the clock speed and is measured in megahertz. The other one is cache size. Cache memory is a small amount of very fast memory that is built into the CPU. Blocks of blocks of instructions and data that are used by the CPU are copied from RAM into cache memory, along with the associated memory addresses. If the CPU needs to access a memory address, it first checks the cache memory to see if there is a match. If there is, then it accesses the contents of the cache version. That is, if you have a CPU with large cache memory, it means that you have higher performance than a CPU without cache memory. The other one is number of cores. A multi-core processor is a single computing component with two or more independent actual processors. A dual-core processor contains 2 cores, and a quad-core processor contains 4 cores. Each core can process instructions independently of the other cores. The biggest performance gain when using multi-core processor is when the software has been specifically written to run on multiple cores. So a multi-core CPU has higher performance than a single-core CPU in the same clock speed. And now actually talk about history of CPU.
The history of CPU goes long before the thing we call CPU, as known as Central Processing Unit. But CPUs produced in the late stages of the 19th century, and in the middle of this century, engineers were just starting to use electronics to manipulate the data. And in those days, the idea of central processing unit did not exist as we know it today. The main reason for this at that time computers was not so large enough to define the functions of the central processing unit from the rest of the computer. Here is the brief timeline of the advancement in the CPUs, and I'm going to talk about the most important advancement for me. And before beginning, I want to say that there's a little difference between CPUs and microprocessors, and the main difference is that microprocessors at that time was the general purpose CPUs. What I mean by that, it means that microprocessors used in the factories, like machines. It was the cheap version of the CPUs we know today. And the first microprocessor was introduced by Intel and Busicom. They were the partners for creating the first microprocessor, and it was named Intel 4004. In the 1972, the company, the Intel first launched its Intel first 8-bit microprocessor, and it was named Intel 8008. The next main advancement was in the 1978, and Intel introduced us the microprocessor named Intel 886, and this microprocessor is the ancestor of the CPUs we know today as x86, because it ends with the 86, and all processors with the ending of the 86 can use the same codes written in one of these. For example, in the 1985, the Intel launched its 32-bit chip, and it named as Intel 386. If you write a assembly code in the one of these, you can run that code in either of these. It was the main purpose of the x86. The next important advancement important announcement is the 1995 and the Intel introduced us the Intel Pentium Pro. This is the actual first high performance chip for the workstations and servers, and this CPU is the ancestor of the Intel Pentium CPUs we know today. And the next in year 2000, Intel Pentium Pro introduced to us, and it has the 42 million transistor. With that, in that time, AMD also introduced us an CPU named AMD Athlon, AMD Athlon 64, and it was the first CPU that had 1 GHz speed. 1 GHz speed, and the next main advancement, I would say, is that happened in the 2005 because AMD also introduced us in this year the AMD Athlon 64X2, which is the first CPU with the dual core. It means it had 2 cores in it. And the next in the 2011, AMD also made a first in the history, and they produced the first 8-core CPU. And I want to continue with that. Moore's law.
Moore's law is 1965 observation made by Intel co-founder Gordon Moore, and the number of transistors in CPU doubles approximately every 2 years. But today this law is losing quality because transistors have shrunk so CPU is warming up. In this point, 4004 Intel first processor and just 2,300 transistors. Today, a processor has approximately 2 million transistors. In 2002, we can buy 2.6 million transistors with $1, and 2015 years we can buy 19 million transistors. Where can we use processor? Today world can use CPU for many areas: computer, mobile, iSport, camera, sensing machine, military file, and more areas. But we use different processors for different areas. For example, need to be more durable for space station, or need to more processing power for server and cloud. Quantum processor and computer. What is the quantum computer? A quantum computer is any device that uses quantum mechanical phenomena to perform calculation and manipulate data. What is the difference between classical bits and qubits? The biggest difference between standard and quantum computer is that standard ones are using classical bits, meanwhile quantum computers are using qubits. How it works? Classic bits can only be in one state at the same time, which is true or false, as known as 0 and 1. But because of the quantum uncertainty, qubits can be 0 and 1 state at the same time. Why quantum computer? Processing more data for AI data mining, data analysis, and faster and Microsoft, IBM, Google, Intel, NVIDIA, and many big technology companies interested in quantum computer. You can see quantum computer and quantum processor. A popular CPU. And there are many processor manufacturers on the world. Texas Instruments, ZF Microdevice, Central Technology, Intel AMD, PowerPC, Qualcomm, Samsung, Apple. Intel'in most popular processor, Intel Core X series, Intel Core i9, i7, i5, i3. Also, Intel Xeon processor for server and workstation. AMD most popular processor. Qualcomm Snapdragon 845, Snapdragon 650, Samsung Exynos series. Apple. Why?
Thank you for listening to us.